In this video, we're going to do a quick review of lines and slope-intercept form from algebra because we need these skills in order to discuss paired data. So let's start with reviewing points, lines, and the coordinate plane. When we talk about lines, lines connect any 2 points in a plane. In the xy coordinate plane, points have 2 coordinates, x and y. Remember that x is the horizontal axis, y is the vertical axis. The coordinates of a point describe the point's location relative to the origin, 0, 0, which is right here. So the coordinates of a point are directions on how to draw it. From the origin, how far do I go side to side? How far do I go up or down? So for example, we want to plot the point negative 3, 5. Well, negative 3, that's in the x position, so that's telling me go back 3. So from the origin, I'm going to go back 3. The next coordinate is the y coordinate. Y has to do with up and down. It's positive 5, so that's telling me from where I just left off, go up 5. And where I land is where the point negative 3, 5 sits in the coordinate plane. You should be able to do 2 things. You should be able to sketch a point given an ordered pair. We're going to use that skill to make our scatter plots. You should also be able to pick those coordinates off if you're given a graph with a point already drawn. That's also how we read scatter plots. The other thing we need to know how to do is use the equation of a line. So we can see in this picture, we have a line in blue that's connecting the point 0, negative 2 to 1, 1. Equations that produce graphs that look like lines are called linear equations because mathematicians are not very creative. And one way to express a linear equation or a linear relationship between 2 quantitative variables is with a slope-intercept form equation. And this is probably the very first way you learned how to write the equation for a line way back in middle school. And we write linear equations in slope-intercept form as y equals mx plus b. And I am hoping for those of you who are younger or still in high school that sounds vaguely familiar. M, which is the coefficient on the variable x, is the slope of the line. Remember that slope tells us about the tilt. Big slope means a steep line, small slope means a shallow line. And we calculate that slope as rise over run. B, which is the constant at the end, is the y-intercept of the line. And the y-intercept is where the line crosses or intercepts the y-axis. So for this graph here, I need to identify 2 things in order to write its equation. I need to identify its slope and its y-intercept. For the slope, I start at the point on the left and I go towards the right. To get up from the lower point to the upper, I have to go up 3. My rise is 3. My run, how far I have to go sideways, is 1, from 0 to 1. So to get from my first point to my second, I go up 3 and over 1. So my slope is 3 divided by 1, rise divided by run, which is 3. So I know the coefficient on my x term is going to be 3. The next thing I need is the y-intercept. Where does that line touch the y-axis? And that's this point right here. And that's crossing at y equals negative 2. I want the y-coordinate. So b is equal to negative 2. My constant is negative 2. Putting those 2 values in to slope-intercept form gives me the equation y equals 3x minus 2. So if I wanted to give directions to recreate that line in blue to another mathematician, I would write down the equation y equals 3x minus 2. When we start looking at lines of best fit later this week, we are going to use this same form, y equals mx plus b. You'll see this letter change. We'll call it something else because statisticians like to be different, but this form will be exactly the same. Let's go ahead and do 2 examples. So we're going to work with lines. First, we're going to write the equation of a given line, and then we're going to graph a given equation. So for this first picture, it says write the equation of the line below. And we know that if I want to write an equation, I want y equals mx plus b, where m is the slope and b is the y-intercept. So let's, in this picture, identify those 2 pieces of information. In order to figure out slope, I need 2 easily identifiable points. So I'm going to pick this point and this point because those are really easy for me to count. I can see that this is the point 0, negative 3, and this is the point 3, 0. They're on an axis, so they're easy to label. In order to get from the point on the left to the point on the right, I have to go up 3 and then to the right 3. So my slope is rise over run 3 over 3, which is 1. The next thing I need is my y-intercept, which is where the line crosses the axis, and I can see that that's right here. And the y-coordinate at that point is negative 3. So my y-intercept is negative 3. Putting that into that slope-intercept equation, I get y equals 1x minus 3. I know that 1 times anything is itself, so you will more commonly see mathematicians write this as y equals x minus 3, because 1 times x is just x. When we wrote this equation, notice that the first thing we did was find the slope, and the second thing we did was find the intercept. When I'm graphing, I am going to do those things backwards. I am going to identify and graph the y-intercept first, and then use the slope to find a second point. So looking at my equation, I know that the constant at the end is my y-intercept. So I know my y-intercept is equal to 4. So the very first point on my graph is at 4. 1, 2, 3, 4. And I know that the number in front of the x represents my slope. And they gave me a constant negative 2. And I know slope is rise over run, meaning I should have a fraction. And if I want to turn a whole number into a fraction, I just put it over 1. So negative 2 is the same as negative 2 over 1. So what this tells me is to get to my next point from the point I just graphed, I'm going to go down 2, and I'm going to go right 1. So down 2, right 1, and that puts me right here. So my line should connect those points. you'll notice that when I drew that line, I extended the line from one edge of the graph to the other. We should always do that because a line extends in both directions forever. So don't stop with the points that you drew. Extend it in both directions. All right, if you have any questions on this video or anything else from week 6, feel free to send me an email or catch me during office hours. Otherwise, I'll see you in the next video.